Gang, we're going to be talking about network isolation. And whenever we do that, it's important to recognize that our need for isolation is much like if you were to, let's say, start a new office. And so you rent some space in an office building, you get the third floor. Well, the third floor, when you receive it, is one big, vast bullpen. It's just big open space. There are no partitioning walls, there's no offices, there's nothing. It's just a big space. And you say to yourself, this isn't going to work. I might need to have a private conversation, and I can't do that unless I've got some walls and some doors and some locks. In fact, I'll be lucky to have any good conversations because there's going to be so much noise from everybody else trying to have their conversations. I won't be able to make sense of what I'm saying. I won't be able to work well here. So you go ahead and you define some blueprints and you start putting in partition walls. You set up offices. You put locks in those offices. You set up sections for different departments to be isolated from each other. And you're giving yourself two key benefits. You're giving yourself an advantage in terms of performance, and you're giving yourself an advantage in terms of security. When we do this in our networks, whenever we set up different subnets, we're able to then define that in order to reach another subnet, another set of network space, well, you're going to have to cross the threshold of a router. Suddenly we can have policies and access control lists and quality of service, all those things we need to control security and performance. Now there's two ways that we really do that as far as we're concerned in both a wired and wireless environment. In the wired environment, we're going to do that through VLANs. In the wireless environment, we of course do it through SSIDs. And remember, an individual access point here could host multiple SSIDs. So for example, this access point hosts an SSID called guest and another one called internal. Host them both. A client joins the guest SSID, and therefore it will be assigned a layer 3 IP address that allows it to communicate locally with anything else on that same SSID. And have to route to reach anything that is a part of a different SSID or really a different subnet, no matter where it is. Internal, same thing. They're going to be given an IP address. Why did I do this? Well, because I want the folks who are guests to my network who just need internet access to be able to connect to the access point, get an IP address, and go. And I want other devices to be able to connect without having to set up a whole nother access point to a different SSID, which is associated with a different subnet. Now, what we're going to see is that this isolation that we have in the access point level is great, but we have to make sense of it in the wired network as well. In the wired network, we create that same type of virtual separation that is, instead of two physical access points with two physical different SSIDs, we logically do it with two SSIDs on the same access point, right? When we get to the switch, I don't want to have two separate access points connected to two separate switches connected to two separate interfaces of a router, right? That's too much work. So I'm going to use VLANs. That's what virtualizes it in the switch world. So on the switch, we're going to have VLAN IDs that are going to be associated with the same subnets that internal and guest are associated with. Now, what's going to end up happening though is the wireless LAN controller is going to play a large role in how we do this in our CAPWAP-based environments. Because our access point is going to, remember, allow us to have a tunnel to the controller. So think about this. Our client here connects to the access point. The access point talks to the controller. We authenticate that guy. Then we now have the ability to manage data through there. So what's going to happen is every time data goes through here, we're going to have an access point to controller tunnel in which the client guest data is going to go through that tunnel, reach the controller, and then it's going to be de-encapsulated. And then from the controller, because the SSID of that guest will be identified, it will exit the controller using the guest VLAN ID, in this case VLAN 20. When internal goes through its data tunnel from the access point to the controller, so that's one connection there. It will then leave the controller with its identity in place, with its own particular IP address, using the internal SSID of VLAN 30. So we're going to have an association. Part of managing wireless LAN controller is defining the association between SSIDs and VLANs.